Thank you everybody for attending this this lecture. We are going to discuss things that I'm guessing most of you know in terms of DevOps and continuous integration. But the thing I want to raise in this lecture is the importance of considering the requirements in this DevOps activity. Most of the time, people they think that requirements are things that come out of the blue, and this is like an input for an ongoing process, which is DevOps. But in my work with together with Sébastien Moser at UQAM, we are trying to bridge the gaps between developers and requirements engineering in general. So let me see. Yeah. The content of this talk is going to be hopefully half lecture and presentation of concepts and me providing insights for you, and the next part will be a little demonstration. And if we don't have time to do this demonstration fully, you'll see that anyway it's in a GitHub repository. You will be able to do it as a practical application of this lecture if you want. So who we are. First of all, I should mention that maybe some of you attended it, but this lecture is a recycling for me of a tutorial that we did together, Sebastian and myself, in requirements engineering conference last year. It was virtual, and we used this material, and when we discussed the content of this course, I thought this would be suitable for the winter school. So I'm basically reusing this material. So I'm sorry if some of you already attended this tutorial. They can just hear with only one ear. It's going to be the same content. So Sebastian is a professor in Montreal. He's going to move soon, so don't look for him in UQAM if you go there. And I'm going to do this lecture by myself today, and I'm a professor in Toulouse. I have some connection with some colleagues in Russia, especially in Innopolis University, and we basically work on requirements engineering, but we try to make this activity practical and closer to the developer. This is the kind of thing I'm going to discuss. I'm not following the discussion part of the chat of the Zoom. So please, Anton, if you see anything coming that I should consider in the chat, feel free to. I mean, anybody, feel free to interrupt me if there is anything you want to ask. I would like this session to be as interactive as possible. I'm talking to my computer right now. It's a bit frustrating. I wish I would be with you guys, and I guess it's the same for you. I'm pretty impressed by the number of attendees, and I guess you have my contact in the website. So feel free to contact me after this talk if you want to dig into the principles. So we are going to address all these elements. We're going to talk about DevOps, requirements engineering, user stories, acceptance testing, continuous integration, and deployment. So when we think of software, there's two aspects that are very important, and I'm guessing this is something you have done in some other courses. There's this V&V activity, validation and verification. So first of all, to make sure we are on the same page, what I like is not just the definition of those two terms, is the fact that they address the two important part of a coin, of the same coin to me, which is making sure that the product is of quality that you deliver. And those two aspects is first doing the right thing. You have to develop the right software. So what right software is the one that the user has in mind. So this goes to the validation side, where you need the user to tell you that yes, this is the right system he wanted you to develop. On the other side of the coin is the verification aspect, and this might be a little bit independent of the first one, but it's very complementary, and it's the fact that you're building the system right. And building the system right is making sure that you did not introduce any mistakes in the codes and things like that. So you can deliver the system right, but this is not the right system, the one the user has in mind, and vice versa. You can deliver the right system, but maybe you did something wrong in the process. Okay, so this is the two aspects we are going to address. One of the buzzwords right now is DevOps. Despite the buzzword, the nice thing is that it goes a little bit further than agile. You might have already an agile class where it was important to put the user in the loop, first of all, and secondly, to use an iterative and incremental process where you slowly build the system. The DevOps approach goes a little bit further by including also the deployment and the monitoring of the current software used by its customers, by its users. There's different variation of DevOps. For example, one of the challenging part of DevOps right now is DevSecOps, going to the security aspects of DevOps. Maybe there's some lecture in this winter school about that. Another one is to take into consideration the values of the company. You can have DevOps, but at some point, especially here in the monitoring aspect, you need to integrate the fact that the DevOps is not just about the software that is delivered, but it's also about the quality, in terms of the quality in the sense of the value obtained by the company with this software. You can have the best software you want. If the company doesn't make money, for example, with this software, it's not too much good for the company. So this is also another aspect that we won't address too much here, but which is also very important. I'm sorry, I'm trying to remove the Zoom. No, I cannot. Okay. I hope your vision of the slides are not disturbed by my Zoom parts that are on my screen. So
no, that's fine. We see
okay.
on the slides.
Okay, perfect. Thank you, Anton. This is the classical cycle. If you want, you identify some important value from the company. Those value implies defining stakeholders, which are called persona in the agile approach. Those persona, when you discuss with them or when you think about their problem, you define epics, big stories, if you want, big concerns. We use, for example, to describe epics, I like to separate, for example, functional properties from non-functional properties, for example. Quality development, performance could be described as an epic, and an epic will be a set of different user stories. I'm guessing this is acquired from most of you in the audience, but if it's not the case, we can go back a little bit. But the easiest way to get a good idea of what the system should do is to describe that by stories. If you have studied the agile methods, you know that stories should be attached to test to be able to assess that you have reached these stories. So it goes to unit tests, and those unit tests, when they are combined, they provide you the demonstration of an acceptance scenario. And this acceptance scenario, most of the time, you would like it to be described at the beginning of the process. So this is the final element of the cycle that is presented here, but you would like to have these acceptance scenarios as soon as possible, especially from the description of the value that are important for the company, for example. So this is the frame that we are going to address today. This is like a rough picture to describe the environment. Most of the time, you have a certain domain with stakeholders, users. So this is not just the user of the software. It goes a little bit beyond. It could be the manager of the company, etc. So they all provide the elements in the middle, which are concerned by the requirements engineering activity. So it could be requirements themselves, in the sense I would like the system to do this or to do that. Most of the time, it's to those requirements are there to satisfy a goal from the stakeholder point of view. For example, if you're in charge of the security of the company, you have some goals that nobody could crash your system from a network access, for example. Yeah, as an illustration of those goals and those requirements, you can provide user stories, and there's also some requirements that I like to separate from the classical "the system should do this" or "the system should do that" requirements, which are constraints. Those constraints can be the easiest example of constraint is a regulation. For example, you're in a certain domain and you have I don't know, you have an environmental constraint, for example, that you should not use more than this % of CO2 consumption, for example. And so this is a regulation constraint. This is not really it can become a requirement to the system you are going to develop, but it comes from outside most of the time. And this is the kind of thing that you most of the time receive from the stakeholders. All those elements are the elements that are taken into account by requirements engineer, sometimes specialist people who elicitate those elements and provide lots of modeling and documentation. When I mention modeling, it could be as simple as just a text as first, but more and more, and I guess you all know that more and more companies use model instead of text. Why do they use model? Because those models, they can make them tell something. You can manipulate model, you can transform model, you can prove that model are correct and things like that. So modeling is not just drawing boxes and arrows. It can be mathematical formulas. It can be a description of the behavior, a formal description of the behavior, and things like that. So I put into the same category the documentation that goes with these requirements and their modelization to cover all these aspects. And then you have all the company employees that are in charge of developing the system. They have many of such elements. So they have the test, they have the tool to manipulate those models out there for example, model checking or theorem proving, and they have to deal with all these elements. So when we talk about DevOps, most of the time there is this technical stack that is involved. This is the kind of thing we are going to talk about, and what I will insist is in the top side of this slide, which is the language to express acceptance test, which is Gerkin. But in the classical technical stack, and in the one you will find in the repository I will provide you, one of the classical basic element is Docker. The nice thing with Docker is that you can deliver easily the software in a sense that you don't have to worry too much about packages and libraries and things like that. The way you produce the software is also automated. Repositories are versioning repositories and versioning techniques are involved, such as Git. Continuous integration is involved in order to build the system. As soon as there is a modification in the source versioning repository, and in order to build this model, if we consider the Java environment in this talk and in this tutorial, we are using the Java environment for simplification matters. I know you guys in Russia, you really enjoy Python, for example. But this is also true for Python. It doesn't matter. In Java, the most popular right now tool building system is Maven, and we will see an example of the kind of thing we can do with Maven. And over this this production of the system stack, you have the testing stack, which allows you to make sure that before deploying through continuous integration, for example, before deploying your application, you make sure that the tests are okay. And we will see something that which is at the heart of this presentation, which is Gerkin, which is a behavior-driven development language that I would like to convince you that this is really an important tool to master and to use as much as you can. And yeah, I have presented the requirement engineering environment. I have presented the DevOps, and the idea of this talk is to see how we can bridge the gap between the two. Well, this is maybe a slide I'm going to skip. It was just to show you that it is not just in software that all these things are important. This is a slide taken from a system engineering method, which is very popular in France and abroad. It's called SESAM. It's a process, if you want. It's a methodology to develop systems. And what I like in this slide, just to remind that you have expected properties that you want in your system, which will lead to requirements, and you have also descriptions. And descriptions can be models, they can be regulation rules and things like that. And most of the time, people forget to describe the environment of the system. If you think of the last software you have developed, I'm pretty sure that you had a lot of information about the system itself, but you had very few about its environment, who is using it, what is the purpose, and these kind of things. And this slide was for me to remind you that this is important. I'm not insisting. I'm pretty sure you all know why it is important to make sure you work properly on the requirements, because if you miss anything at this point, you can reach a very, very bad situation, such as the one illustrated here, where everybody is doing his best, but at some points things are not aligned. And you might be familiar. So this is a very naive and very exaggerated illustration. But you must be all familiar with this very famous Airbus problem, where at some point they tried to assemble parts of the I can't remember which Airbus brand, I mean which model of flight it was. It was not the A380. It was before that, but the first pieces they wanted to assemble. You might know that Airbus is a European company, so some pieces are done in UK, some pieces are done in Europe, in Germany, some pieces are done in France, and the assembly line, the final assembly line is in Toulouse, in France, where I come from. And the very first pieces they tried to assemble together, there were like several inches missing. And they couldn't plug some cables, and it was because of a misunderstanding in the UK using the inch system and the French and Germany using the metric system. So this illustration can be really effective in critical systems also. So the idea is to illustrate in this lecture how we can formally, I mean, maybe not formally, but precisely go from the requirements to user stories, from the stories to the definition of acceptance scenarios, and then from those acceptance scenarios to the tests. And then we won't go into the next steps, but the idea is to go from the test to the code, and then to the code, from the code to the deployment. And then while the system is deployed, we monitor it, we get feedback from its usage, and then we go back again. We go back again in the sense that the requirements should be something dynamic. Maybe the usage of the system is going to either refine or maybe sometimes modify the requirements. And this is why Agile is so popular and is so successful in some context, is that you don't consider the requirements as a finite set of sentence that you don't touch at all. It's something that should evolve either with the time, either with the change of regulation, or so basically the idea is to build an environment where you are agile to support any changes in those requirements. And you want to reduce the time between a change in the requirements and its actual impact in the deployment of an application. The most successful software companies right now are the one who are able to deploy as fast as possible, and as of course with as much quality as possible, a new ID, a new feature, or a new change when they see that the customers they would like something in the software, they can easily add it. So it can be in the software context, as I just described, but it can be also in a very complex system such as the aeronautic environment. For example, until very recently, the Airbus company considered that because of the aviation aeronautic regulation rules, all the planes crossing the Atlantic should have 4 engines because of the quality of the engines at the time, because of the consumption of gas, of kerosene that those planes were using. It was impossible to build an aircraft to carry people over the Atlantic with less than 4 engines. And this rule has changed recently. But it's very, very critical for a company such as Airbus to wonder, okay, what is the impact on all the process, on all the development process, the cost, the quality insurance, the certification process, etc. What is the impact of such a change? What if we go from 4 engines to 2 engines to cross the Atlantic? What are the consequences? And this is something very difficult to estimate and to evaluate. And why it is so difficult to evaluate is because most of the time you have you have a lack of formal traceability between all those elements. But today we are going to focus on software because it's a software engineering winter school. So the question we are addressing in this lecture is can DevOps, which are mostly dedicated to coding and to development, can influence the way requirements are expressed. Of course, you guessed that my personal answer, the one I would like to convince you, is that yes. When you know that you have such a nice and iterative process such as DevOps to help you build your software, then you should take that into consideration and maybe write your requirements a little bit differently. Just to refer to some connected areas to what we are going to talk. You'll see that this is if you know domain analysis, if you know DDD is domain-driven development or design. It's a way to develop object-oriented software, such as the objects you have in your software are close to the vocabulary that is used by the clients, let's say, of the code. This is also an initiative to reduce this gap between the requirements and the code, because most of the time people, for example, there's no way you can make a manager read your code, right? He doesn't want that, but most of the reason is that there's no way he can understand the code. So domain-driven design aims at reducing this gap by making sure that the concepts that are manipulated in the code are very close to the concepts that are in the requirements. Another aspect that we are going to use is the TDD BDD thing. So you might have learned that it's a very good idea to write the test first before coding. This approach is called test-driven development. So what is test-driven is if before you write your code, you first and this is very illustrative in a bug. I hope you have this process. When you find a bug in your software, the first reflex is to correct the bug. But you should not correct the bug. You should first replicate the bug, right? This is something you might have learned in your software course. The first thing is to replicate the bug, because you might have find the bug accidentally. Maybe it's deeper than that. So first, even if you want to explain the bug, you need to illustrate it. So you write a first piece of code that reproduces the bug. So basically, it's a test that fails. Okay, and then you fix the bug. Then you patch your code and you make sure that the test is not failing again, and everything is green. Why is it important to do this? Well, it's important because then, first of all, you can document what you have done and why you have applied this patch to your code, so that there is this documentation dimension. But the other dimension which is important is that this way you're ensuring that whenever you are going to modify things in your code, you won't reproduce this bug again. So this goes in the direction of avoiding regression of your code. So and if you take this approach in the testing activity, in the debugging activity, and you go into extreme, then even for developing your piece of code, you write the test first. So this is also interesting because you are going to be able to assess that your code is actually doing what it's supposed to do. This is the first reason. The second reason is that if you really think deep into your tests, I used to say half of the job is done, but maybe it's even more, maybe it's a bit less. But if you consider deeply how you are going to use this piece of code, so by doing so you write some tests, then you start to unconsciously thinking of how you are going to do this. Okay, so this approach is called TDD, test driven, and in addition to that, this is what we are going to see today. There is a very nice approach that which is called behavior driven development that helps you writing those tests, because people don't like to write tests. Tests are sometimes complicated. Tests are sometimes repetitive, and you would like to be able to generate, for example, tests as much as possible. So this is the kind of thing we're going to see. Another approach which is related, we are not going to talk about that today, but I'm pretty sure you had courses in formal requirements. I come from the formal methods area. The idea of formal requirements is that if you write your requirements formally enough, then you are able to somehow test them or validate them or make them say something. For example, make them say that there's no way you can develop a system that fulfills the requirements, because, for example, some of them are contradictory. This is very important. If you find a way to detect automatically inconsistencies in your requirements, this is a very good approach, because even before spending any energy developing a system, you already have identified some problems. I'm pretty sure you have all seen the V cycle and the impact of the cost, the impact in terms of cost on a development where something is wrong at the requirement. When something is wrong at the code, this is the very bottom of the V cycle. You can fix the thing very, very, very easily and cost effectively. But if you find something in the design, for example, then it is even more costly. But design is not the worst. The worst is at the requirement. If something was wrong at the requirement level, then this is very, very, very critical and very costly. I don't know if you're familiar with this very this example of requirements problem. You can dig an internet for the video of the Volvo president who tested himself the automated emergency stop system of one of the car they were launching. So there was this guy driving the car in front of the Volvo CEO, and the car didn't stop. So it was a complete failure live. The press was there, and so they start to investigate why the car was not stopping. The 100 tests before, the car was stopping, and the day the press was there, the day the car was released, the car didn't stop. And it turns out that because of this pressure of the press and everything, the guy driving the car was accelerating. And in fact, in the controlling system of the car, people had not identified that on the requirements it was written somewhere that if the driver is accelerating while there is an obstacle, this is because he's doing it on purpose. For example, you decide that either instead of braking hardly, you want to avoid the obstacle. Okay, and if you want to avoid the obstacle, sometimes you need to accelerate. So if the driver is going into an obstacle and is accelerating, you shouldn't stop. You shouldn't. So the automatic stop system was disconnected while the driver was accelerating. So this is the kind of thing that could have been detected at the requirements level, and that was completely ignored through all the development, because in all the tests, driver were driving classically in front of an obstacle. But for this particular day, they wanted to show to the press how impressive was the car. So the guy accelerated as much as he could, and then he found the very precise hole in the requirements that lead to the failure. So requirements, formal requirements do not ensure that everything is going to be perfect, but at least it allows you to do some testing at the some evaluation at the requirements level. Okay, and there is a popular activity right now if you're interested in research area, because systems are more and more complex, so they involve more and more people from different domains. So there's a need for aligning vocabulary between those domains, but this is also something that we are not going to cover today. Okay, I think I need to accelerate a little bit. Yeah. Going from the requirements to the persona, so trying to organize the requirements in terms of who they involve, and then placing some priority. I'm pretty sure you all know the Moscow acronym to separate from the requirements which one are absolutely necessary, so it's a must. What are really desired by the clients, which is should, what is like optional, which is good, and what is really not important, but maybe for the future. So some people call this very last category will, some people call it even want, so that okay, we won't deal with this feature. The next, so this is the first steps of requirements elicitation, and going from requirements to persona to epics to user story. The next step is to evaluate the risks, and then to deploy a strategy to start either with the riskiest, most important user stories, or by the easiest and more important user story. This is a policy in terms of developing the system. So the question is how you go from a list of tasks and pieces of software to a full product. So the most popular right now approach is to not develop the system as the V cycle prescribed. You know, work on the requirements, do some design, and refine the design, and then code the system, develop the system, and then verify it, and then test it, and then validate in the client. This is too costly sometimes. And the second effect is that you, for a long period of time, you don't deliver any value to the company. So if you stop the project at some point in the left process, then the company get nothing. While if you stop the process at any point of time in the right part of the process, then even if the customer doesn't have the full value he was expecting, at least he has something. This is the classical mantra good quality of the agile method. You iteratively and incrementally go into the direction of the future system. So instead of splitting the system into pieces, you are going to identify big properties in the sense of epics, in the sense of use of the system, and then you are going to refine those epics into user stories. This is where we connect the requirements with the tests. When you describe a user story as an illustrative scenario of the use of the system, so as a requirement as such, you should make sure that this user story, so these pieces of all the requirements, should have good properties. And among those properties, I'm pretty sure you all know this INVEST acronym. So a user story should be independent, in the sense you should not, I mean, it should not depend on other user stories. Otherwise, you should group together. You should group them together. It should be negotiable in the sense that it should be discussed with the client. It should be valued in the sense that it should bring something to the customer, to the client. It should be estimable. So you should be able to get an idea on how hard, how risky, how difficult this particular user story is going to implement. It should be small in the sense that while we have an iterative cycle, this user story should fit into one of those cycles, if possible. If it's not possible, maybe that means that this user story is too big. And this is for today, this is the most important quality of all. It should be testable. Even if the test is not written yet, of course, when you describe a user story, sometimes you don't have any idea of how you're going to test, but the way it is described should lead to some tests at some point. If you write the user story in such a way that there's no way you can write a test, then it is badly written. And okay, this is a good example of a bad user story. As a user, I'd like to be able to use the entire functioning application. This is very vague. There's no way you can just test this apart from having the user play for infinity with your application and things like that. Okay. So this is the classical INVEST versus vague. A user story which is vague is vast, arduous, gargantuan, unclear, and eternal. The person, I'm going to go quickly to that because it's not the most important part of the talk. First, you should really identify the typical user. A persona is not a real person. A persona is a fake person, but who has some characteristics. So, for example, here you have Alice and Bob. Both of them are very specific features. They are very specific goals, and why it is important to identify those people involved in the company, because they are going to be illustrative and they are going to be at the initiative of a user story. So a user story will always start with as a persona. Okay, so as Alice, who is Alice? Oh yes, Alice is the croupier, and she has a specific goal. So I want to, and then there's the description of the feature of the system. The system should allow Alice to do something. And the third part is really important. Most of my students, for example, they forget about the third description of the user story. And this is very important because this helps you consider why the feature is important in the system. Sometimes as a developer, we tend to consider that we don't care why. Oh, the systems want a red font in his front page. Okay, I write the text in red font. Okay, but in fact, the reason he wanted red is to make sure that the thing was important and noticed by the client. But knowing that, you might help him or her going back and say, well, you know, in this particular page, which is already has a lot of red things, a red font is not a good idea. Maybe you should put it in another color. If the real need is to attract the attention of the user, for example. Okay, so this so what is very important. I'm skipping the other elements of the definition. Things like what is the business value, how many points in terms of difficulty to develop it requires, and things like that. Of course, the ID. Every user story should have a precise ID. But what we are more interested here is the acceptance criteria. Every user story not only should have a reason, a rationale, why do Alice wants to do this, but there should be an acceptance criteria. How are you going to demonstrate to Alice that this that your software has this feature? Okay, so this doesn't have to be automated necessarily, but at least it is the description of how you are going to demonstrate that you have taken into account this user story. Okay, and this is the thing we are going to see how to write. So let me skip this one. Acceptance testing. This is what we are interested in, and here in this talk, and this is where we are going to use, and I'm going to show Gerkin as an example of such a language. Yeah, every time you add a new code, you should be very, very careful. So in your software engineering class, you have very, very early, I guess, learned that you should test your code. Sometimes the teacher was providing maybe the tests. You had to write the software in order to pass the test, and at some point you learned how to write your own test. So this is a Java typical test, but it is not easy to read because it involves knowing how the application works. It implies knowing the class names, the class methods, and things like that. So the question we ask, and why we raise the level of abstraction at the acceptance test, is that could we find a better way to write tests? Well, this is where behavior and BDD comes at place. If you see the two things, the one on the top and the one in the bottom, in fact, they say the same thing. You have a context. In the test, we initialize a game. In the scenario that is described in natural language at the top, we provide this context. So given a new game, then there is in the scenario there is a situation we want to assess, or you want to test, or you want to describe that this is the kind of thing that can happen in the scenario. So you have this when clause, which is also in the test. In fact, in the test we write a code that illustrates what happened if Bob provides submit a new hand in the. So this is a poker game. I forgot to mention. It was maybe obvious for most of you, but this is a lot easier written in natural language. So when Bob submits the following cards, of course we have a little bit of convention to describe the cards. So ace of clubs and kings of clubs, etc. So when Bob submits the following cards, then it should be if we want to estimate the highest card in this hand, the highest card should be the ace of clubs. So this is the very same thing, the one on the top and the one in the bottom, but the one on the top could have been written by a client. It could have been written by a CEO. It could have been written by someone who has no idea what is the language that the software is developed. Okay, so this is the kind of thing we want to write, the thing on the top, and hopefully the thing on the bottom will come maybe automatically, maybe not automatically, but at least we will be able to play with the one on the top. Sorry. So the nice thing with this acceptance testing language, such as Gerkin, is that they are integrated in the development IDE most of the time. So this is an example in IntelliJ. I personally use VS Code, and of course there's a plugin that supports Gerkin, which is called Cucumber. What is the interest of using an IDE to write those acceptance testing is that you benefit from the same kind of tools that you benefit when you are a developer. So you have completion, you have colorization of the syntax. Sometimes you have validation process in the sense, oh, you forget this clause or you forget this one and things like that. So according to the level of I mean, if you have commercial tool, you have even more characteristic, but at least you're writing your acceptance test a little bit like you would write a program. Of course, this is not a program. This is a description. So Gerkin or this BDD approach provides you a way to describe a domain-specific piece of text, which looks like a code, but a very high-level language, and with some kind of precise syntax. So you have scenarios, you have given, when, then things, you have and. You see, it's not a repetition of them, it's a repetition of and, but and has a special meaning, because if you put an and after a when, then it's the end of the when, not the end of the then, etc. So you have a little piece of syntax, and this is why you need to use a tool to write those things properly. So to create a new requirements description, you will need first to define the feature, which is going to give us the name of the functionality, and then you write the scenario that explains this this functionality. And this is very requirements compatible. In fact, you could ask the writer of the requirements to provide. So here in this tutorial, we use user stories, but this could be true with the classical requirements. You can ask the very same person that write the requirements or that write the user story. The very same person can provide you with the acceptance test. If you provide him or her the proper tool and the proper syntax to write those things, then they will provide you. So that means that the acceptance tests are going to be written by the user itself, not by the programmer. You will get the programmer, and the next you will get the acceptance test written in natural language almost. And the next step, I mean, your responsibility as a developer will only be to map. Okay, what is the meaning of given a new game? What is the meaning of when Bob submits blah blah? What does this mean, submitting? What is a card? What is QD? All these elements of this language are completely unknown by the customer. It is known by the customer in the sense of the business. The customer who is a poker player, he knows exactly how to play poker. He knows exactly what he wants from the system, so he can express those acceptance tests in terms of business rules, in terms of domain-specific constraints or scenarios, let's say. Okay, but then you are the developer. So you have to do the mapping. You have to do the mapping between what is given a good new game, what is when Bob submits, and then that means that you are going to write under each statement. So this part of this slide I'm illustrating right now, this is written by the developer, because the developer knows that in order to start a new game, then you have to call the new method, I mean the new construct on the game class, and put that into the attribute, the game of some other class. Okay, because you're developing in Java. You would be developing in Python, you would write another piece of code. Okay, you would not even use a programming language. You would maybe put a little bit of script here, something that execute and do the given a new game. Okay, I'll come back with the strange characters in those clause. Okay, and then you have the when clause, and then you explain what it is to submit a card, and then what it is to define the highest card, etc. I don't go into the details, but so just to give you examples, let me try to stop this set of slides and go back to. I have a set of examples somewhere I would like to share with you. I think it's here. Yeah, you see, this is a very I like this example because this has nothing to do with computer science. This is a scenario that I wrote because I wanted to apply what I'm talking about today. I wanted to apply it to my one of the activities that I have as a professor is to review PhDs. I say, okay, I have this process. I need to write a report on a PhD, and sometimes I forgot, for example, to check plagiarism. And one time it was very critical. So I say, okay, how can I not forget to write a report? Well, I decided to, because I use LaTeX anyway to produce my report. I say, okay, if I want to make sure I'm not forgetting again, then I need to use continuous integration. So every time I send a report about a PhD, it is not written. I mean, I don't write myself the final document. The final document is a PDF, and the PDF is produced by a process taking into account a report that I write, of course, in a source, in a text file. I'm pretty sure you all know LaTeX, but let's consider is a markdown thing or an ASCII doc thing, or it's an input in terms of text. I write this report, I press a button, and if, and only if, all the tests pass, then I produce a PDF, and this is the report I'm going to sign and send it to the colleague who have asked for me to review this PhD. Okay, so this I say, okay, because I want a process, why don't I use the thing I'm teaching, this behavior-driven development thing? After all, I'm building a report in the form of a PDF, and I want a nice process too. So I started to wonder, can I express the property I'm interested in? And this is only 2 examples. And in that situation, I didn't go further than that. But just to show you that this approach can be used even if in your day-to-day life. As soon as you have a thing that you want to repeat all the time, and you don't want to write tests all the time, this is the kind of thing I've written. For example, so this is the bottom part is the one about the plagiarism. So, given a PhD thesis to review, and the reviewer John Smith, this is not really important. I can remove the "and" in fact in this one, but never mind. Then the PhD.pdf, so the initial source, let's say, that I'm evaluating, should be checked against, the T is missing here, against plagiarism. You see here, I had no idea how to do that. And this, at this point, it is not important. I just wrote this kind of thing. Okay. Another one is, for example, I'm considering that if I am a reviewer of this PhD, that means that I am an expert on this topic. And if I am an expert on this topic, then the PhD should cite me somewhere. Even saying that, okay, I don't do like Jean-Michel Bruel. Okay, so the rule, I managed to express this rule as this one. Given a PhD thesis to review and a reviewer John Smith, then this is the thesis should cite John Smith's work. Here you can see how to do that, right? It's pretty easy. I take the input and I simply do a search in the initial text, and if I find John Smith somewhere in the text, this test will pass. The next one, in fact, I use a tool at the university, so I had to find a trick to make sure that the tool have been used. So, for example, I use the tool, I produce a report from this tool, and if the report is there in the set of files, then this test goes. If you're interested in how I implemented those tests, but this was part of the implementation. This was part of how I work, because I worked with PDF, because I worked with LaTeX. The corresponding tests of those features were specific. Okay, but I can provide this feature to a colleague and ask him, okay, according to your context, the way you write, if you use Word, for example, instead of LaTeX, okay, you might have more, it might be trickier to check this or that, but that's your problem. Here is the set of quality metrics, the set of scenario I want you to validate. This is the acceptance test from a client point of view. Okay, this is an example. This is another example. The slide I'm using right now, not the previous one. The previous one, there were keynotes that I borrowed from my colleague Sebastian. But the one you're seeing right now, they are in HTML, and same thing. Every time I produce a course material, I want to make sure that this course material has some quality. And how do I check those quality? Well, for example, I have stated that given an ASCII file, I'm using ASCII, which is a kind of markdown input to generate those HTML slides. Given an ASCII file, all the URLs should be active, in the sense that there should not be an error on those URL. And you can find easily some tools that check that on an input. So basically, the test that is generated from this scenario is pretty simple. I just simply open a terminal and I launch the tool, and I verify that I didn't get any 404. Okay, those are other examples. This is something I wanted to share with you, because maybe you found my examples very small and easy, but you can do a more complex thing here. In this example, you want to check different situation. In the same scenario, you say, okay, if I get 100 pencils with price 1 and one paper of price 35, then the customer checkout should be 121.5. So you can provide a list of value in this very simple and very intuitive way of providing all the values you want to test in your scenario. Another one, maybe. Do I have another one? Yeah, maybe I can go back to the strange characters. I forget to. I didn't want to talk about at first. Where are they now? Oh, they are on the slides. I will go back on the slides after that. Yeah, maybe you wonder, okay, I've written these kind of things, but now I have to write the tests that correspond. But the nice thing is that the tool that comes with this language, which is Cucumber, I mean, the most famous tool that goes with the feature, the writing of features is Cucumber. The nice thing is that when you launched Cucumber on the features, then the first time you launch, I mean, the first time you try to execute this thing, the tool fails, of course, because he has no idea what we request the product list mean. He doesn't have an idea of what then we should receive blah 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 mean. Okay, so it tells you that. It tells you, okay, if you want, so everything is like yellow, so it's not red. It's red when you did a mistake on writing the feature. So if you did a mistake writing a feature, for example, I don't know, you instead of when you forget the H, okay, then you have red. Okay, the feature is not correct. Okay, you correct it. Then the feature is yellow. I mean that, okay, it's correct, but I have no idea how to evaluate it. Okay, and it tells you what it needs. It tells you, okay, I want you to tell me what we request the product list mean. It tells you what we should receive blah blah mean. So it tells you exactly what you need to do to implement. So it provides you a skeleton of all the correspondences between the features and the code that it requires. And this is where, in my example of the PhD thesis, I started to add little pieces of script in my case, because it was not a programming language. It was just a scripting that I would like the continuous integration to launch. Okay, so this is very rich and very, I go back to the slides now. This is a very rich language. Okay, where do I start again? Yep. And I will show you. Okay, yeah, I wanted to go back to these characters. You can even use a regular expression. So, for example, the when means that you are going to you are going to map all the sentences that have submits the following cards, blah blah, with only one correspondence description. Everything that is after the colon, which is in the parentheses on the right, you will then extract them as a data string. And the first one, you are going to extract it as a player string. And then those things, the one captured in the left part of the sentence and the one captured in the right part of the sentence, they are going to be parameters of the correspondence code that you write. Okay, you are going to transform this data into a new AND. So that means, of course, that you have a constructor that is able to start an AND from a string, and you are going to be able to also send a string as a submitter of the game. Okay, so this, making short, I have only shown you the tip of the iceberg of the kind of thing you can do with features. It's called feature, those scenarios, what I've called so far integration acceptance tests in the Gerkin Cucumber vocabulary. It's called simply a feature. Okay. So yeah, this is only effective. I mean, this way of writing acceptance test, as I mentioned in my PhD example, this way of writing acceptance test is only effective if you also put that into the context of something like continuous integration, DevOps kind of iterative process, continuous process. okay, because integration is complex and unpredictable. So of course, we are going to use CI, continuous integration, to do that. Well, I guess you're convinced that CI is good for lots of good reason. It helps you do increments, meaning integrating frequently in an automatic way, so that you don't have to wonder every time how you build. You just build automatically. You write once for all most of the time. You improve, of course, the building, but most of the time when you build a write for the first time, then you continue building the same way. And of course, before, I mean, after building the software, but before delivering it, you are going to be able to trigger some tests. So the classical pipeline is the one. It starts on the right. Okay, the developer have pushed some new change in the code. So the repository, the source code controller repository, fetched the changes to a continuous integration server, which build the system, test the system, and check whether it has failed or succeed. And if it has, whatever the result is, both whatever people you want are notified. You can, for example, send an email to the manager, or you can send a notification to the developer, etc. And then back again, the developer maybe find that the test has failed. He fix the failure and push the changes and back again. Okay, this is the classical because this is a classical pipeline. So if you go up to the if you apply these DevOps things at the final user level, then this is what we have used in this tutorial, and this is the kind of thing you will see in the repository in a minute. Then you can check before you can clone, you can build, you can test, and only if everything goes well, then you can release, and you can download the people can download the last release. Okay, well, this was just an example of how it might sound for those of you who have no idea what continuous integration is. This might sound this might look a little bit complicated, but you should see it as a very pragmatic and simple way to write things. So this is the machine we are using. This is the command we are launching at when the CI start, and this is the kind of thing we do. I mean, everything is written in a specific language, which is called YML. And it's pretty easy to learn how to write those things. And most of the time, you don't even write those things yourself. You just find good examples somewhere related to the kind of thing you do, and you just reuse them. Hands-on demonstration. Oh, we only have 20 minutes, right? If I'm correct. So I'm going to share two things with you. The first one is this URL that is on the top. I let you, maybe I can copy paste it on the chat. Let me try this. I'm going to close this. Let me put that in the chat. It's going to be easier for you. So this is just a shortcut. I'm going to use it anyway. So I won't have the time to I mean, this is like a half-day tutorial. I'm summarizing in 1 hour and a half. So I'm sorry, but you will have time if you want to play the game, and I will be really interested in getting feedbacks from you guys. But this is a complete tutorial. This is the requirements. If you want to do it, I'm just going to demonstrate it for right now. You have the steps, and you can freely contribute even. So in this tutorial, I'm going to go very quickly through all the steps. We don't start from zero. We provide a little bit of building environment in the terms of a Maven tool, a Maven code. And as long as you have a starting repository with the main repository and the test repository where you are going to put your Java code, then you you build an empty application that does nothing. Okay, so you start your favorite IDE. You add the first dump application that only says welcome to this tutorial. You apply the same Maven package, and you get your result. Okay, so you start with a little application that does nothing else than saying hello, but you are already in a versioning system because you cloned you clone the initial repository, and you check that your building tool Maven here works. And this is important to do it manually before you want to do it to make it done by a continuous integration system. You have to check it manually, of course. So the next step is to create the scenario. So of course, if we want to make sure that we are going to be able to write those scenarios, then we need a little bit of Java things such as JUnit to write the tests. And you write your first test manually before using Gerkin and Cucumber. You need to make sure that your testing environment is working. So first you write a little test manually, very simple. So by the way, I forgot to mention, but the application is a simple drink ordering application. So you check, and here we use TDD. So we write the test first. And of course, those tests don't pass because you are using classes that do not exist, but you're using your editor to write those things. And then using the Maven environment that is provided also, you make the test pass. The next step is to use the Cucumber, so the acceptance test environment. So of course, you need to add a little bit of dependency in your Maven to get the library that are going to run the Cucumber, and then you write your first acceptance test. Okay, given Romeo who wants to create an order, when Juliet is declared as a recipient, then the order does not contain any drinks. So when you initialize everything, the order is empty, basically. So you write this and you execute them. And when you execute them, it says, oh, I don't know what this sentence means. I don't know what this sentence means. So those 3 lines here, you just cut and paste from the execution. And then you simply put them at the right place at in the right, using the right libraries. And then you only have to write this. I mean, even this one is empty. This is the exact thing you get from the execution. Okay, for now you just throw an exception, and you have these things running, but of course not running. And the next step is to, so this is if you remember what I said about the TDD, this is making the test fail. Okay, it is correct in sense of Java, but it does nothing. It just throw a pending exception. So it is correct syntactically, but it does nothing. So the test fails. And then the next step is to make the test pass. So then because you wrote the code, you know what this means to Romeo wants to create an order. You first create an order, and then you set the owner of this order to be Romeo. So this is where, for example, if you do this tutorial using Python, this will be the only part where you change this. I mean, of course, with the library and things like that, but this will be part of the execution, because this is what Cucumber needs. When Cucumber detects in your feature Romeo who wants to create another, then you will need the piece of code. Okay, and then you execute, and then the test pass, and everything is okay. And then you can improve your scenario. You can add more, etc. This is the next step. You can make the scenario more precise. So, but by more precise, we can specifically use some values for orders, and for example, if Seb wants to create an order for Jean-Michel and put those 3 commands to the order, then the order should contain 3 drinks, and 2 of them should be Pepsi Coke. Okay, so you can be as precise as you want. This is just an illustration. The tutorial goes also to direction that I've not mentioned, such as mocking. Mocking is that is a way to use acceptance tests when some part of the application are not developed. This is a very interesting part. I have no time to go into the details, but if you're interested, you should have a look at it. It's very interesting. For example, in this tutorial, we don't have the database to store the orders and things like that. So we mock it. We write a little bit of code that do exactly the same thing as if we would have the database. Okay, so I skip this part, which is about mocking, and then you can have a very deep and very detailed list of scenarios running. So the next step is to play a little bit with the application. In that case, we do REST service. I'm skipping this just to show you the result. I'm pretty sure there is a there is an example here somewhere. Oh, this is I've been a little bit too far. Yes, it's a web service. So you here we go. Yeah, this is a trace. So the web server is running on this particular server. The user have just simply used some specific URL to add. Instead of using the terminal, we use the web browser to add an owner. So this is the API we have developed. Same thing, few piece of lines, and that's it. The next step is to wrap everything into a Docker image, and this is where we can say that we have built the application, in the sense that we provide a Docker image of the full application. So thanks to the continuous integration, we end up as soon as you have used the continuous integration, then you end up with everything in the same thing. Just to show you that the pipeline is quite simple to express in YML, and yeah, you end up with an application that is available. So it simulates the deployment of the application. So just it was a quick overview, just to show you how I think it would take you several hours only to have a full pipeline from the requirements expressed in terms of acceptance scenario to deploy the application in a sense of a Docker application that is running. You will be able to deploy all these things together in few hours, and this is how it works at the end. I think we have 5 minutes left. I would like you to I hope we have time for questions. I don't know. Even if we don't have time for questions, I have set up a little test for you. I'm pretty sure you know Socrative. So if you guys would like, after the talk, you can go to Socrative.com. You don't have to register anything, right? For those of you who don't know, you just go there, Socrative.com. You log in as a student. You don't need a login. You just click on the student part. It's going to ask you a room. The room number is JMB. That's my initial, Jean-Michel Bruel, 42. You just write this room number, and I'm going to just launch the quiz that I've prepared for you. SSE 22. I don't think I have time to paste it, but I don't need your name. I'm going to shuffle the questions, shuffle the answer. You can have the final score. And well, maybe I'm not going to shuffle the question because the very last one is just a feedback. If you would like to give me a feedback on this lecture, I will be happy. And that's it. So you have time to do that after the talk. You don't have to do it right now. But I see that some people are already connected. Thank you. But yeah, feel free to do it whenever you want. And that's it from me. But I would like to